Hello everyone. Uh, I'm starting a new video. The name of the video is rolling process, so the concept of rolling of sheet metal or metal basically. This is part of the module of introduction to forming processes. I am assistant professor Deepak and I teach in the mechanical engineering department of FCRIT Vashi. A little bit about myself right now. I am an assistant professor. My name is Mr. Deepak Devasagam, and my highest qualification are Masters of Engineering in the branch of Mechanical Engineering. A total of 15 years of teaching experience, and my areas of specialization include manufacturing, production, logistics, supply chain management, and metal 3D printing. And I'm currently pursuing my PhD in the field of metal 3D printing, and you can reach me on my email at d.deepak@fcrit.ac.in. So in this video, we are going to be looking at the process of rolling. Now, what is rolling? Rolling is one of the basic types of forming processes which are utilized for manufacturing of components, products, materials, and your things that we utilize for our engineering work. So in the forming process, no material is removed, they are deformed and displaced. And the basic types of forming processes are forging, extrusion, rolling, sheet metal working, and rotary swagging and thread rolling. So here you guys can see example of forging. So where you can see this particular hot rod is being shortened or made lesser in dimension using a hammer-like object. So this is like a application of impact force and making the component force into a way that we want, and this process is called as forging of process. And the process that I'm going to be talking about is the rolling process. So here you can see a sheet material being squeezed between two rolls, and you can see the decrease in the thickness, and this material is also red hot, and you will have a little bit of water cooling, and this process is called as the rolling process, which is the third operation that you guys can see over here. Now, a little bit about the forming processes. A classification of metal forming is divided into two major aspects. The first one is called as bulk deformation. The other one is called as sheet metal working. So sheet metal working, you guys can see an example of the sheet metal working in this particular video. So here you guys can see a simple sheet metal being rolled between rollers which have like certain grooves. So each of these grooves creates this indentation, or I'll say embossing of the material. So you guys can see it is having a certain shape. So this particular process which you guys can see is an example of sheet metal working. So in that you have bending, shearing, deep drawing, deep and cup drawing. So all the components that you see in your kitchen, like your ladles, your forks, your spoons, all of these are made under the sheet metal working concept, which is the type of metal forming operation. Now, of course, we are not looking at this. We are looking at right now the bulk deformation process, and one of the major ones which is called as rolling process. So as the word bulk you can look at, so it means you are going to be working with a significant thickness of material. Okay, you're not going to be looking at very like thin pieces, and we are also in this particular classification also looking at forging, extrusion, and wire and bar drawing. So whenever you guys look around where you're sitting, okay, you'll be seeing certain metal components like your window frames, your chairs which have metal components. So these operations are able to create those particular components. Now in the previous video I talked about casting. Casting is in general for objects which are kind of like block-like structures, but this particular process creates structures which are very long in nature. Okay, so let's get into the depth of the processes. So the first image you can see that is the rolling process, where a metal plate or a slab like structure is made to be squeezed between two rolls, where you can see force on the top and force on the bottom squeezing that particular material, and you're getting a thinner material. The second one is called as forging operation, as you saw in that video, in the photo previously. So what you're doing is you're taking a component and you're applying impact force on it. So when you apply impact force on it, it gets squeezed into the structure that you want. Now, example of forged components are of course the coins that are in your purse. So you guys can see your coins have those small projections on the top and the bottom. So those things are created by the forging operation. Next we have the extrusion process. So in this extrusion process, what we have is we have initially some of the raw materials being put into a cylinder like structure, like how your injections are, and then you apply force on that particular material. So what happens is this material is squeezed out of an opening, and the shape of the opening creates the type of structure which is created. So if you have like a round sort of opening, a round bar like object will come out. If it has a square like hole, then a round square bar will come out. So this particular process is utilized for creation of your bars, your pipes, your tubes, and structures like that. Then the last one is the wire drawing operation, or simply the drawing operation. So instead of pushing from the back, in this particular operation you will see the material, rather than being pushed from the back, is actually being pulled from the front. Okay, so you here what you do is you take a little bit of component and you start pulling it out. So again here this opening will also create the structure of that particular material which has been extracted. Again, you can have square, round, whatever types of opening that you want, and that type of particular processes, that particular product will be created. This is utilized more for creation of thin components like your electrical wires and things like that. All right, now let's come to the actual process that we are going to be discussing in this particular module, and this is the rolling process. Now, what is this rolling process? It is a bulk deformation process in which the thickness now we are looking at the concept of rolling process. Now, what is the rolling process? The rolling process is a bulk deformation process in which the thickness of the work is reduced by compressive forces which are exerted by two opposing rolls. So here you guys can see there are rolls. One is rolling in the counterclockwise direction, the other one is rotating in the clockwise direction. So this kind of squeezes the material between these two rolls, and at the same time, because these rolls are huge in diameter, they are also applying vertical compressive forces from both sides, and the rolls rotate to pull and simultaneously squeeze the work between them. Alright, so here you guys can see an animation of the work being squeezed between two rollers. So here you can see like a thick material. Now as the material gets squeezed out between them, it flattens, and at the same time you can also see that the width of the material is also increasing, and simultaneously the thickness is decreasing. Now one thing I want to let my viewers know, so the people who are following the video right now should understand that the volume before the rolling and after the rolling, okay, both are same. So here you guys will see that the thickness is reducing, so automatically you have to understand that the width will also increase, and at the same time the length of the component is also increasing. So the thinner and thinner that you start to squeeze this, the longer and wider the component will be. So volume is not going to change you are not like cutting anything. Here this material is simply being squeezed into another particular component. So this is one critical aspect that many of the students usually fail to understand. They think that as the thickness is just decreasing, nothing else is decreasing of that particular sheet metal. No, the material's length is increasing and also the width is increasing. Now we can reduce the width by providing guards on both sides. So what happens is then the width will remain same to whatever a degree that we can control it to, but the length will of course automatically increase to ensure that volumes both before and after the rolling operations are the same. Now rolling process is categorized into two types. So the first one is called as the flat rolling, which we just now saw an example of. The second one is called as the shape rolling. Now, the flat rolling is used to reduce the thickness of a rectangular cross section. So you guys must have noticed that sheet metal will have a cross section which is basically rectangular in nature, like a thin thickness but a very long length or width. Okay, so here on the bottom you guys can see the flat rolling. You have like a slab which is then reduced in thickness and which produces plates or sheets, and then these plates and sheets are then put in coils. And if you have billets, those particular like square like structures, those can also be squeezed. Now the other type is called as the shape rolling. Now in this shape rolling you have this particular type of cross section which is square in shape. Now this structure can be modified and squeezed and made it into an I-beam structure. Okay, many of the students have already seen these structures whenever there are buildings up around, or bridges or frames, any sorts of metal frames. So you will always see this I sort of structure. Now this structure is also created by rolling, but this particular type of rolling is called as the shape rolling operation. Now what are these blooms, billets and slabs that I have been telling about? So you have to understand that before rolling operation, casting is the original first process where you take molten material and then you convert that molten material into a rectangular block like object. Now the block like object is called as ingots in the engineering term, and these ingots are rolled into three intermediate shapes. Okay, so first thing, as soon as you have the casting liquid metal, you drop it into like a big tub where it forms these ingots, and these ingots are then shaped into blooms, billets and slabs. Now what are blooms? Blooms are components which have square cross sections which are 230 centimeters square or larger, and these are rolled into structural shapes. The smaller ones are called as billets. These are square cross sections but having 40 by 40 mm square or larger pieces, and these are again rolled into bars and rods. Okay, so blooms are usually converted into structural shapes, billets are converted into bars and rods. So here you guys can see on the bottom an example of a bloom and a billet. Now what is the length of this? Length of this can be decided by the engineer who is designing these particular components to whatever requirement is of the customer. So if the customer says I want 1 meter, you create it of a length of 1 meter. If they want it out of 100 meters, so you increase that particular length to till you get that particular components. Now the last type is called as slabs. Now slab is a rectangular cross section where the width of the structure is greater than twice the thickness. So this particular key concept you have to understand whenever you are talking about the concept of a slab structure. Now these particular slabs are then converted into plates, sheets or strips which are much thinner in nature. Now to understand, I just want to share a video with you guys where the rolling process is shown on materials. Alright, so let me play this video. Alright, this video is about the company SSAB, where heavy industry is utilized for making these rolled components. So I'll directly skip to the process that what we want. So here you guys can see the slab structure which has like a red hot. Red hot means the material is just now coming out of the casting furnace, and it is now starting to cool down little by little, but still they are kept a material at that particular temperature. Now everyone has to understand, whenever a material is red and your metal is being worked on, most of the cases in this temperature is called as the recrystallization temperature. Recrystallization temperature means your crystal structures, your crystal lattices inside the materials, which are FCC, BCC, these have not been formed yet properly. Okay, they are in the process of forming. So if you keep the temperature above the recrystallization temperature but below the melting point, this material, when it is being squeezed between the mills. So here you guys can see there are two rolling mills which are reducing the thickness. So you guys can see there are two more mills on the top and the bottom, so they are applying even more force. So when the slab is very strong and very thick, you need to apply even more force, and you can then reduce the thickness. Now you guys just now saw the material go forward and then it reversed back. So this sort of an operation can then reduce the thickness drastically. Here you guys can see in this particular process 22 centimeter thickness of slab is being reduced to 3 centimeters. So that is it doesn't happen in one stage, it happens in multiple stages, forward and backwards, and each time you reduce the thickness little by little. Now whenever you do it, you guys can now see that slab which was having a certain length has now significantly increased in length. All right, so the equipment that is required for a process like this to handle materials which are very large, very thick, is significantly larger than any of the small workshop tools that you guys have probably seen in your institute or in your college, wherever you are learning. Then once your material has been completely created of the thickness that you require, then you roll it into a coil like this. Okay, and you get your finished coil and then you let it cool down. Now these finished coils sometimes are given a little bit of more finishing operations, then they are allowed to cool down completely before they are shipped out, and you will see in a minute, in a second, how that particular coil will look after it has cooled down. Now this is the example of the sheet metal which has been created by the rolling process, and it has been coiled down. You can't of course take a very long sheet metal and transport it very easily. So what you have to do is you have to coil it in this particular structure, and I'm definitely sure all of you guys have seen these particular coils being transported on these huge trucks, okay, to various locations. So these sheet metal coils are then taken to whichever companies, like your automotive companies, and those companies which are utilizing sheet metals. So what they do is they take these sheet metals, then they cut small pieces, and then they create their components, like your car body structures, your train body structures, your cupboards of metal, or any of the structures which require those plate like structures. Okay, so as I was telling you, rolling has two basic process categories. So based on the workpiece geometry, it is either flat rolling or it is shape rolling. So flat rolling is used to reduce the thickness of a rectangular cross section. Shape rolling is a square cross section, and it is formed into the shapes such as a I-beam structure. Now based on the work temperature, most of the times rolling is done under hot. Okay, so most common due to the large amount of deformation required, because what we are wanting to reduce those big thickness of slab materials into a very thin sheet metal piece. But at the same time, there are processes which are doing this rolling process in cold temperatures. So cold rolling is used to especially produce finished sheet and plate stock. Now I'll be letting you know about these particular two concepts in a little bit of depth in the further slides. Now coming down, I want everyone to understand that shape rolling, you can create whatever shapes you want of length that your customer requires or you require to produce in your particular company. So you guys can see these rollers, they don't have like a cylindrical structure, they have like a profile. Okay, so as the material is squeezed between them, automatically the profile of the component gets changed. And if you want to create something like an eye structure, so it will not happen immediately. So multiple these rolls will then slowly shape that bloom or billet into the eye-shaped beam that you require. Now there are two major types of rolling processes according to temperature of working. The first one is called as the hot rolling, the second one is called as the cold rolling. Okay, so the breakdown of the ingots into the blooms and billets is generally done by hot rolling. So the material generally just comes out of the casting process, so it is like red hot, not gone to the room temperature level, so it is really hot, and this process is called as the hot rolling. And this can be then converted into plates, sheet, rods, bars, pipes, or rails. And then in the cold rolling process, this is usually what we do is, after the hot rolling is done, the material is still not having a very good surface finish. Okay, usually oxides form on the top and the bottom. Sometimes there is a little bit of cracks, sometimes there is a little bit of other aspects which you don't want. So what you do is you take the material at room temperature and then you pass it between rolls. So what happens is the surface finish is automatically increased, the mechanical strength increases, and there is a close control of the size or the dimension of that particular sheet metal components. Now a very critical aspect of understanding rolling process is the microstructure process. Okay, so I have shown, I'm showing over here two images. First is for the hot rolling, the second one is for the cold rolling process. So for the hot rolling process, you guys can see initially the material as after casting, it has these large grains. Okay, so while casting, as the material is solidifying, the atoms or the molecules of the metal, they start to bind together, they form these crystal lattices, and while they are forming these crystal lattices, these form large grains. Now you guys are of course seeing the two-dimensional image, so you have to understand this is also having a width coming out of the screen. Okay, so there is like this thickness also of that material. So automatically, of course, you have to understand that these grains are not just circles, they are actually kind of spherical in nature. Okay, so think of like large rocks put together in this particular fashion. Now this sheet metal or this particular ingot slab is then pulled between these two particular rolls. They are squeezing and compressing that particular slab into a thinner dimension. When you do this, what happens to these grain structures? Okay, so these ball-like structures or stone-like structures, what they are done, what we do is we deform them and elongate the crystals or the grains. Okay, so the grains get squeezed and they form these kind of like elliptical like objects, and as they come out, okay, as they come out, they then start forming smaller balls. Now you have to understand, right now the temperature is above the recrystallization temperature at the hot rolling process. Okay, so now for steel, most of us know that for the recrystallization it is somewhere around 700. Aluminium, there is also a certain recrystallization temperature. So whenever the temperature is above the recrystallization temperature, these elongated grains automatically transform themselves into smaller grains. Okay, now these grains are having almost a similar nature to the material previously before rolling, and they have the same material mechanical strength after rolling also. Okay, but they are slightly smaller and uniform in structure. So the mechanical strength of the product which is formed by hot rolling doesn't change too much before and after the process. You have to understand this very clearly. And as the material starts cooling, then the crystallization happens, because the recrystallization temperature now goes lower below the temperature, especially for steel it comes below the 700 degrees Celsius and it starts to form the actual product. Now some of us, what we do is, after we get these particular products, we are not happy with the surface finish on the top and the bottom. Now as I told you, this temperature was at recrystallization temperature. As it cools down, the top and the bottom layers will react with the oxides, oxygen present in the atmosphere, and they form metal oxides which will be in the form of scale or rust, which we actually don't want. So what we do is, we take these particular finished components and we put it under another set of rolls, but this time the temperature will be at the ambient temperature, which is around 30 degrees to 25 degrees Celsius. Now here you guys will see that the structure, similar structure, okay, the grain like structure is again being squeezed between these two particular rolls. Okay, but the temperature is not above recrystallization, it is at the room temperature. Now what happens is, while it is being crushed, okay, you will see that the grains in the middle don't undergo any deformation, but the grains on the top and the bottom, they are completely distorted and crushed almost. Okay, so what these elements do is, they form these thin but long grains and they are compacted, so you get a very good surface finish on the top and the bottom of that particular component, and this also ensures that the accuracy of the component which comes out is also very accurate to what we require. So this is the two major differences between a hot rolled component and a cold rolled component. And if you start to cut these particular two components, you will find it is much easier to cut the hot rolled component versus the cold rolled component. Why? Because the grains at the top and the bottom, they are very hard as compared to the material which is inside the middle. So cold rolled components usually have a much higher hardness as compared to the hot rolled components at the top and the bottom of that particular surfaces of the component. Okay, so this is one important aspect that I want the students to understand very, very clearly. And as I was saying, in the hot rolling, the slabs are heated initially to 1100 to 1300 degrees Celsius. This is of course lower than the 1500 degrees Celsius of the steel. So the temperature in the last finishing stand varies from 700 to 900. This is like just above the recrystallization temperature, okay, but above the upper critical temperature to produce uniform equiaxed ferrite grains. And the flat plates of large thickness is passed through different set of working rolls, while each set consecutively reduces the thickness. So you of course are not going to reduce significant thickness, so you're not going to have like 20 and then directly 2 or 3 mm. So you have to reduce it little by little till you obtain the final thickness of the component. Okay, so this is the hot rolling aspect. As I've already shown you the video, I hope you guys have understood it. And as I already told you, of course, as the volume starts decreasing, as the thickness of the material starts decreasing, the length of the section starts to be faster moving out of the rolls. So especially if you have thin sections, automatically as they are coming out of the rolls, they are going at a much faster speed as compared to when they are entering into the rolls. And here you guys can see in the industrial aspect, when we are wanting to cool down the components, we use water and we significantly cool down the material very, very quickly to the ambient temperature. Now, the cold rolling, of course, as I already mentioned, it's carried out under the recrystallization temperature, and this introduces work hardening aspect. As I was already telling you, it becomes significantly harder as compared to the hot rolling component. The starting material for the cold rolled steel sheet is pickled hot rolled breakdown coils from continuous hot strip mills. So basically, always components are taken from the hot milling aspect and then hot rolls, and then you are passing it through the cold rolls. Now the total reduction achieved by cold rolling generally will vary from about 50 to 90%. So again, over here you can obtain a significantly very high reduction in thickness, but this requires more pressure as compared to the hot rolling. The hot rolling, the material is still malleable because of the hot temperature, so you can use lesser force and the material will easily get squished. But here the material is at room temperature, so that means it is significantly cooler, so you require to apply more strength to reduce it. The reduction in each stand should be distributed uniformly without failing much below the maximum reduction for each place, and generally the lowest percentage reduction is taken place in the last pass to better control the flatness, the gauge and the surface finish of the materials. Now of course, one of the major positives about the cold rolling is it provides products with superior surface finish. Due to the low temperature, no oxide scales are formed. It has better dimensional tolerances as compared to the hot rolled products, and the cold rolled non-ferrous sheet metal may be produced from hot rolled strips, or in certain cases, certain alloys, copper alloys, it is cold rolled directly from the cast state also. So we know that copper is actually not as hard as the steel or other materials. You can directly take it out from the cast state and directly start using cold rolling mills, and you can create the required thickness that you want. For the sake of students ease of understanding, I have created kind of like a comparison distinguish between table. So you guys can see the very first point, the cold rolling or the cold working operation, the temperature is below the recrystallization temperature, whereas in the hot working the temperature is above the recrystallization temperature. And here because task of compression leads to strain hardening, and here the strain hardening is due to plastic deformation. Cold working decreases the mechanical properties of metals like elongation, reduction of area and impact values. This actually improves the mechanical properties like the tensile strength, okay, but the hardness is better in cold working, not in hot working. Here in cold working, crystallization does not take place. Crystallization does take place in hot working. Material is sometimes not very uniform because in cold working the material is not allowed to move very easily because of the case of strain hardening. So it sometimes bulges out in certain places, sometimes it cracks. But in hot working the material is uniform, more homogeneous, and there is of course less risk of cracks, more risk of cracks. In cold working, this increases the ultimate tensile tensile strength and but decreases the resistance to corrosion. In hot working, the ultimate tensile strength, the yield point and corrosion resistances are basically unaffected. So before after, the material does not change too much. Then internal stresses, residual stresses are produced during the cold working. In hot working, it is not produced. As I said, cold working requires more energy, hot working requires less energy. And finally, in the cold working, no oxidation of metal takes place, and in hot working, heavy oxidation takes place, and you require to do some additional chemical treatment like pickling, which is required to remove the oxide. I hope the students have understood the processes and the way that the microstructure is created in the components. So whenever you are utilizing components from the market, you have to understand it, whether it is cold rolled or whether it is hot rolled. In general, it is hot rolled, but in certain specific places, you would come across cold rolled steel. So you have to understand that they have much harder work surface. Okay, so whenever you try to cut it or you try to mark it, it will be significantly harder as compared to materials which have been hot rolled. With this, I end this lecture, this video. I thank you all, and I'll see you later.